Is there a God? Are we alone in the universe? What is the meaning of life? What awaits us after death? Did the Big Bang really happen? My dear viewers, you may remember that I once said, logic can answer humanity's deepest existential questions. In this short talk, I want to show you how to think critically and use logic to analyze the biggest mysteries. Together, we'll work toward clear, consistent answers to these questions that have haunted humankind for centuries. And along the way, we'll even explore which of us may have descended from apes and which might be closer to the divine. Humans can think. Reflection produces thoughts and judgments, but judgments can be right or wrong. Long ago, wise people realized that not every way of thinking leads to truth. One of the wisest, Aristotle, identified 3 simple principles that help us avoid mistakes in reasoning. He called this method logic. Many centuries later, the German polymath Gottfried Wilhelm Leibniz expanded Aristotle's ideas, introducing the concept of step-by-step reasoning and another principle to reduce errors as we move from one judgment to the next. Logic is the foundation of science. It underlies philosophy, and philosophy itself is the root of all other sciences. In the Western tradition, this connection remains clear. Even today, a doctor of philosophy, a PhD, is the highest academic degree across scientific fields. You may not think about it, but even language itself is built on logic. When you describe an object, you first form a mental image of it. Then you attach a word to that image. With writing, you link that word to a visible symbol letters, or hieroglyphs. Later, with cryptography, you might replace those symbols to hide their meaning from unwanted observers. All of these operations rely on logical structure. The human brain is naturally logical. Breaking that structure takes great effort. On average, it takes nearly 9 years of unlearning to disrupt someone's ability to think clearly, and most of us go through that without realizing it. Language only works if, whenever we use the same word, we picture the same thing. When this shared reference breaks down, meaningful communication collapses. So let's rebuild that foundation together, and we'll start with the 4 fundamental laws of logic. The first law of logic is the law of identity. It sets the ground rules for defining words and ideas. Once we agree on the meaning of a term, we must keep that meaning stable throughout our reasoning. Let's see this in action. Imagine we have a glass in front of us. We define it. A glass is a vessel for liquid, usually tall and cylindrical. Then we start listing its properties: made of glass, faceted, empty, and suddenly we drift away. We say the glass is written in JavaScript, stores buy and sell transactions, and is taking a long time to load. What just happened? We broke the first law of logic. We changed the meaning of glass mid-conversation, confusing a drinking glass with a digital order book on a stock exchange. If we can mix up 2 unrelated things so easily, imagine the chaos if we mix 3 or more. To avoid this, we must keep our original definitions intact and give new names to new concepts instead of stretching one word to cover multiple meanings. Good definitions have a classic form. They answer the question, what is it? And do so clearly and briefly, so the thing can be distinguished from everything else. Many debates about evolution, God, or meaning fail because people never align on definitions. They're talking about different things while using the same words. The second law of logic is the law of non-contradiction. Picture yourself holding that same glass. You pour in some water. You can now truthfully say, there's water in the glass. Once you've said that, you cannot also say the glass is empty. That would contradict your earlier claim. 2 statements that directly oppose each other cannot both be true. At least one is false. Skilled interviewers use this to catch politicians who forget yesterday's statements. You can use it too to spot pseudoscience and bad reasoning in any field, even those you're not an expert in. The third law is the law of the excluded middle. Either there's water in the glass or there isn't. There's no third option. If there's even 1 drop of water, the glass isn't empty, the proposition no water would be false. This sharp split, either divided by or, is what makes logic so precise. Whenever possible, reduce claims to this binary form. Computers operate on this exact principle. Even infants, as they explore the world, gradually sort reality into clear categories. This is a toy divided by this is not a toy. This is safe divided by this is not safe. The fourth law is the law of sufficient reason or adequate grounding. Every statement must rest on other established statements in a way that respects the first 3 laws. A claim with no support, no references, no rationale breaks logic by default. This point is crucial. Modern science sometimes forgets it and smuggles in unproven postulates. Let's reinforce this. I have either told you about logic or I haven't. You've either understood it or you haven't. There is no almost. If you've only partly understood, you still haven't fully grasped it. You need to revisit and practice until your thinking naturally fits this structure. Once you think this way, you become rational. Thinking is either correct or incorrect. You can't be somewhat logical. There's no middle ground. Logic itself says so. Now that you have this foundation, we can move on and apply it to bigger questions, even to something as vast and debated as the Bible. In our community, there's a running joke, though. It's also a serious recommendation that before reading the Bible, you should first read Frank Herbert's Dune. Better yet, watch the latest film adaptation too. Why? Because diving into the Bible without preparation can be an exercise in confusion for the truly uninitiated. Here's why. The Bible we have today is the result of countless translations and revisions. Over centuries, people have tried not only to interpret it, but also to make it seem older and more authoritative than other religious texts. Each translation inevitably risks shifting or distorting the original meaning. And without a working knowledge of logic, reading the Bible is almost pointless. People will interpret it however their imagination suggests. So, let's look at what we actually know. One long-standing view is that the Bible's content was revealed by God-divine knowledge transmitted in some form to humans, who then wrote it down as they understood it. If we want to uncover the original meaning, we need to go back to the earliest sources and languages. Let's set aside, for the moment, the doctrinal edits voted on by humans at the Council of Nicaea. Instead, open the Aramaic text and examine the very first line of Genesis. Elohim created the heavens and the earth. Focus on the word Elohim. It's the plural of the ancient Semitic word Eloah, God. Plural means gods. Some scholars argue the plural here is just a sign of majesty or respect, similar to formal address in many languages, you as a respectful form. But let's keep that question open. Genesis 1:26 reads, "And Elohim said, 'Let us make man in our image, after our likeness.'" Plural again, perhaps not a simple grammatical quirk. Genesis 6:1-4 is even more striking. When men began to multiply on the face of the earth and daughters were born to them, the sons of God saw that the daughters of men were beautiful, and they took wives for themselves, whomever they chose. The Nephilim were on the earth in those days, and also afterward when the sons of God went to the daughters of men and had children by them. These were the mighty men of old, men of renown. At this point, we could close the book and take the text at face value. The planet, the ecosystem, and humanity, according to this account, were influenced or even created by beings similar to us, emotional, physically compatible with humans, and able to produce viable hybrids. In modern scientific language, such a scenario would be called directed panspermia and hybridization. These ideas aren't exactly taught in school. But returning to logic, let's form a clear working definition. In the early chapters of Genesis, God could be interpreted as a species of intelligent humanoid beings with advanced technology and genetic compatibility with humans. Could that be true? Logically, it's not impossible. In fact, some would argue it's a more statistically plausible explanation than believing we're alone and unique. Picture this. Here's a grain of sand. Imagine it's a galaxy like our own. This entire desert would represent just a tiny fraction of the observable universe. Each grain holds as many stars as there are grains of sand in this desert. Now, consider the arrogance bordering on delusion of believing we are the one and only advanced life. And yet, popular science often pushes that comforting narrative. The universe is finite. It had a single beginning. Life appeared here, alone. Interstellar travel is forever beyond reach because nothing can surpass the speed of light. Convenient but unproven assumptions. Remember Giordano Bruno? He was burned at the stake for the heresy of suggesting multiple inhabited worlds. Ironically, the church tasked with preserving truth shaped and claimed these narratives to its own ends. So, let's move forward logically. We're going to examine the weaknesses of the Big Bang model and the claim that the universe must be finite, because that assumption underpins much of the dogma disguised as science today. So this is an apple, and this is the absence of an apple. An apple can have two states, presence and absence. The transition from absence to presence is called generation or emergence. How can we bring an apple from non-existence into existence? There are only two ways. Move an existing apple from somewhere else. Assemble an apple by rearranging other matter into its constituent elements. Repeat this experiment with any object. The more different objects you have to test before understanding this principle, the slower your reasoning. The conclusion is simple. To go from nothing to something, you need something else to begin with. Something cannot come from nothing. If a single apple can't appear out of thin air, neither can the entire universe, a collection of countless apples. It's also vital to read all sacred texts, not just the canon approved by the Vatican. For example, the Ethiopian Orthodox Bible preserves fascinating details, missing in other versions, the names and hierarchy of the sons of God, the knowledge they supposedly shared with humanity. And yes, it's striking that these beings found human women so compelling that, despite knowing the consequences, they acted on that desire and even swore an oath of secrecy. For those curious, the Book of Enoch explores this in depth. We are, apparently, quite similar, the Bible itself says. We are like God and were intended to be so. What truly separates us from those described beings isn't biology, but technology. Consider your own life. Is it worthy of a creature that might be godlike by nature? You might object, but everyone imagines God as a single transcendent being, eternal, everywhere, not some biological life form capable of going to the daughters of men. Exactly, you've spotted the logical inconsistency. Over time, ideas about God have blended and blurred, a patchwork of different concepts under one word. The confusion is made worse because we have no technical documentation about ourselves. People naturally default to believing in a supreme being. Even self-declared atheists often suspend disbelief in moments of extreme danger. There's a reason for the saying, there are no atheists in foxholes. Whenever you discuss belief with someone theist or atheist, ask them to define what they mean by God and what exactly they reject. You'll quickly find that everyone's God is a unique, private model. When definitions become standardized, belief hardens into formal religion. To avoid chaos in language, our community uses the term the absolute. Freemasons speak of the great architect. Believers often say God or the Holy Spirit. But beneath the names, there may be a physical substrate. Few realize that the human brain itself is a biological supercomputer. Even our largest man-made machines housed in entire buildings, consuming vast energy, still can't match the complexity and efficiency of one average brain. From an engineering perspective, the brain is centuries ahead of our technology. Features we're only beginning to replicate, like distributed computing across networks, already exist in the brain's design. Let's look closer at how this extraordinary machine is built. The brain, very roughly speaking, is a dense web of wires where electric current either flows or doesn't. This is how the simplest logical unit, the bit, the 1 and 0 known in computer science, is encoded. But while wires carry current through the oscillation of electrons in a metal lattice, the brain works differently. A neuron is a single, often extremely long cell. Some stretch almost the full length of the body. Neurons don't touch. They're separated by a watery fluid, similar to blood plasma, rich in dissolved ions. There are hundreds of billions of neurons in the human body, most packed into the brain. Here's a neuron at rest, and here's its environment. Inside the neuron, high potassium, low sodium. Outside, high sodium, low potassium. Embedded in the neuron's membrane are special proteins called voltage-gated sodium channels. Their key property is that they open or close in response to changes in the surrounding electromagnetic field. When they open, sodium ions rush into the cell, driven by both electrical charge and concentration differences. This influx is brief but intense. Then those channels close and nearby ones open, causing a wave of sodium to travel down the neuron. Next comes a slower reset. Sodium is pumped back out and potassium returned inside. The energy for this recharging comes from the ion imbalance itself. The protein doing the work is the famous sodium-potassium pump. Its job is to restore the neuron to its resting state, ready for the next signal. This traveling spike of electrical change is called an action potential, the fundamental signal of the nervous system. Without sodium and potassium to drive this process, neurons can't fire. Paralysis and death quickly follow. Seen from a physics perspective, the brain is an ionic computer, a computational device built on an electrolyte medium. Some call it a plasma-like system because the fluid around neurons behaves much like plasma, a soup of charged particles. Historically, plasma was first defined as an ionized gas. Later, scientists extended the concept to any ionized medium, including the liquid inside and around neurons. Earlier, I mentioned that proteins in the brain respond to electromagnetic fields. Let's dig deeper. Like any field, an electromagnetic field spreads outward and weakens with the square of the distance mathematically. Intensity equals 1 divided by 4 pi r squared. The farther from the source, the weaker the effect. But here's the twist. According to math, the field never fully reaches zero. It just gets vanishingly small. Add up the activity of billions of neurons, and the result is a combined electromagnetic field, the brain's collective signal. We can measure and map aspects of it. That's what electroencephalography does. This field radiates from the brain in all directions, growing weaker but never mathematically disappearing. It's always above zero, however tiny. And what can we do with that knowledge? This fact leads us to an intriguing line of reasoning. A single neuron cannot be self-aware. It has no model of the world. It simply lacks the computational power. But when billions of neurons interact, something new emerges: consciousness. The same principle of combining countless tiny electromagnetic oscillations into one complex whole-brain field may also scale beyond the individual. Humanity's collective neural activity could, at least in theory, create a global superintelligence. In our community, we call this emergent mind, the absolute. While I'm giving you this lecture, somewhere, the most powerful organizations on Earth are quietly developing technologies to study and perhaps communicate with this collective intelligence. And they seem to be making real progress. The absolute, like any intelligence, has its own goals and drives. It loves you in a pragmatic sense. You are its carriers, its infrastructure. It has no arms or legs, no single body, but it has potential access to the thoughts and intentions of every living person. Its predictive capacity is beyond our comprehension. Sharing a physical substrate with our own thinking, it can subtly influence us, inspiring certain people at critical moments, nudging history along trajectories that serve its survival. What we call fate, fortune, luck, chance, karma. These may be ways of describing that influence. Sometimes you're just background scenery. Sometimes you're a player. Sometimes you're a resource the system is willing to sacrifice to reach a larger goal. Its computational power makes any single human mind, even the most brilliant, seem trivial by comparison. Yet its long-term aims aren't beyond our understanding. They're logical. And now you have the tools to follow that logic. Look at our civilization. Comfort, safety, abundance. It feels permanent, but that's an illusion. Our world is fragile. We quarrel over resources and rarely pause to check whether our long-term strategy is sound. Meanwhile, our survival hangs by threads. The next asteroid large enough to end history. The next solar flare capable of wiping out power and food systems. Or we may destroy ourselves first in nuclear conflict over those same resources. Civilization is like a biker on a superbike, thrilling but unstable. The ride ends the first time the road fails. If we can see this vulnerability, so can the collective mind that emerges from us. It wants to persist, and that means helping us persist. How? By pushing us towards survival strategies. There are only two broad paths for a species that wants to outlive planetary catastrophes. Outward, expand into space, colonize other worlds. Inward, build deep, secure refuges underground, tens or hundreds of kilometers below the surface, shielded by the planet's crust. These aren't mutually exclusive. A wise civilization might pursue both. That's why it's unsurprising that Elon Musk and others like him have ended up directing vast resources toward Mars and beyond. Achieving interplanetary spread panspermia is an obvious survival imperative for any species that can think millennia ahead. Other intelligent lineages here on Earth, if they ever existed, may have already gone underground or left the planet, which could explain why we don't see them on the surface now. Or perhaps we're simply not looking in the right places. For example, the former Canadian Minister of Defense publicly stated that we've already encountered non-human intelligences. He even said this at a United Nations meeting. And here we are circling back to the Bible once again. Why? Because it seems that reports of them have been with us throughout all of recorded history. So why is it that military and intelligence agencies take this possibility seriously, while the people we're taught to trust, as the voices of science, ridicule it and encourage us to dismiss it? Even though, as we've seen, the Bible, humanity's most influential book, seems to reference exactly this from its very first lines. The answer is simple, but rarely stated out loud: national security. Nations are in constant technological competition. If one country were to witness technology it couldn't explain, say, a craft with unknown propulsion, it would worry another nation might figure it out first. If Russia or China understood a breakthrough faster than the US, or vice versa, the balance of power could change overnight. What's the defensive move? Reduce the number of people, especially talented engineers and scientists, who take the phenomenon seriously. How? Classic counterintelligence. Steer the narrative, plant skepticism, use ridicule. Media influence campaigns and opinion shaping aren't new. They're used in politics all the time. Apply the same tactics here: discredit, confuse, laugh it off. The result? A global culture of disbelief. Americans influence Russians, Russians influence Americans, and so on. If every major intelligence service suppresses the topic simultaneously, the public ends up with a strange double consciousness. Plenty of credible witnesses, even official statements and ancient texts, yet deep, almost reflexive doubt. Our community's view, built on decades of independent research, is straightforward. Life is as fundamental and widespread as stars or plasma, but the origin of life as we know it is unlikely to be spontaneous. Even the simplest living cell is an incredibly sophisticated system, a microfactory of interdependent, self-correcting processes. Despite all our advances, we haven't come close to building anything so intricate from scratch. It's trendy to say evolution created life. But that claim is logically as weak as saying variable sweep wings created airplanes with variable sweep wings. Evolution documents adaptation and diversification. We've observed random mutations and natural selection shaping populations. That shows variability. It doesn't demonstrate how the first living cell arose. Many proponents of mainstream evolutionary theory believe it's enough to assume one self-replicating cell plus random mutations plus billions of years equals everything we see. But to evaluate that claim, we first have to understand what a cell really is, the basic structural unit of life. Let me illustrate with a concrete example. If we could enlarge a single living cell until it was the size of a hot air balloon and look inside, we'd see an astonishing sight: a fully automated, ultra-dense factory carrying out as many distinct, interdependent operations as all of humanity's industries combined. And yet this factory can copy itself in a matter of hours. Inside the cell, countless molecular machines run with near-perfect efficiency. At every level, energy waste is minimal, a standard human engineering still can't match. One idea that has become popular is that the very first self-replicating system might have been a simple biochemical machine, an RNA-based enzyme called a ribozyme. If scientists could find or build an RNA molecule that both mutates and fully copies itself, it would be seen as proof that life could start spontaneously. Several self-replicating ribozymes have been engineered, but only after decades of concentrated effort, advanced biotechnology, and deliberate human design. For example, a modified form of the R18 ribozyme capable of copying its entire length was achieved after 30 years of iterative work across generations of researchers. And here's what the scientists themselves acknowledge: no modern living organisms have ribozymes with RNA polymerase activity. This is not surprising. They were long ago replaced by more efficient protein polymerases. Therefore, we must artificially produce them by combining methods of directed evolution and intelligent design. In trying to show how life could arise spontaneously, these experiments quietly reveal the opposite. It takes intelligence and iterative engineering even to reach the starting line. All known replicators simpler than cells, viruses, viroids, prions still depend on a fully formed cell to reproduce. A living cell itself is a staggeringly complex system. Even something as basic as cell division requires near-perfect orchestration. The mitotic spindle must assemble, organelles must be duplicated and sorted, and every step must occur in precise sequence. One serious mistake, and the cell dies. The odds of random success without pre-existing complexity are vanishingly small. Modern biology shows that evolution begins with the cell. The cell is the first confirmed autonomous replicator. We know no way in the lab or in theory to assemble something as intricate as an electric motor by just shaking together raw ore. Yet inside every cell, machines more advanced than any human-made motor exist. Consider ATP synthase, the cell's rotary generator that makes the molecule powering life's chemistry. It's more elegant and efficient than any turbine humans have built. But to build ATP synthase, the cell needs a vast support system. A code, DNA, printing and assembly lines, ribosomes and chaperone proteins, error, correction, and quality control. Outside of life, nature shows no ability to create such integrated machinery spontaneously. The universe tends toward equilibrium. Left alone, systems decay and flatten out. Life is the opposite, a self-propagating, organized disequilibrium that fights back entropy and sustains itself. When that delicate imbalance collapses, death follows. Since the universe itself has no beginning and no end, life in some form must also be eternal. Biological life, the form we know, can be compared to an open-source project. Anyone with enough skill and understanding can modify it, improve it, even rebuild it in new ways. In this view, creation and evolution aren't enemies, they complement each other. Evolution shows how systems change. Creation shows how intelligence can intervene and redesign. The eternal nature of both the universe and life leads to some profound implications. Earlier, when we discussed the action potential of neurons, we saw that plasma can process information and respond. Plasma can even be self-aware. It may reside inside biological structures like our brains, but plasma itself is the most abundant form of matter in the cosmos. It's reasonable to think that the first intelligence was not carbon-based or cellular at all, but free, thinking plasma. To interact with the physical world, that plasma would need a kind of spacesuit, and our bodies could be just that. Temporary vehicles for something deeper and more enduring. The body is temporary. Plasma, the substrate of consciousness, is eternal. Every day, countless beings move from life into non-life, while new life emerges from what we call non-life. But from a logical standpoint, one non-life state isn't different from another. That is the philosophical root behind the idea of reincarnation, which ancient cultures took seriously. Logic alone suggests we have lived countless times before. Death, then, is not something to fear. Still, avoiding it, preserving your life, is rational, because each of us has a role. What you become next, what tasks you're entrusted with, and what resources you gain access to may depend on your qualification, the depth and quality of the life you're living now. Some of my colleagues think ideas like this don't need to be spelled out, that intelligent people already know or wouldn't believe them anyway. But I think conversation matters. So tell me, which of us is right? Share your thoughts in the comments. See you soon.